In section 5.5, we'll look at solving some equations, but this time we're going to look at things that have a bigger degree than just a linear equation with just an x to the first power. So up to this point, you've most likely seen equations like this first one, like this one over here, this 3x plus 2 equals 7x minus 12. And the idea with solving these is that you need to get the x by itself. So you would start by subtracting 3x from both sides. And that would at least get the x's on the same side. And then you'd say, okay, well now I have 2 equals 4x minus 12. And then you would add the 12 to both sides to get the x by itself. And that would get you that 14 equals 4x, and you divide both sides by 4, and you get, once you reduce the 14 over 4, you get 7 halves. And the idea here with these are, and you don't really think about this, is you're getting one answer for x because x is raised to the first power. We don't think about it because the 1 is usually hidden. Now, what we're going to look at is things with, let's say, an x squared or an x cubed. When we just had the x to the first power, though, those type of equations, when we just have an x to the first power and we're just getting one answer, is called a linear equation because it's just got an x to the first power. However, what we're going to start out at least by looking at is at something that has an, let's just say, an x squared in it. Well, what do we do when we have an x squared? We're also going to have an x term, most likely, not always, and then a term with no x's. This is something that's called quadratic. And a quadratic equation will be the actual term we use for these. And I know with quad, you're probably thinking the root of the word quad is, well, quad means 4. Well, you technically do have 4 terms. You have the x squared term, the 3x and the 18, and then you do have a 0 on the other side. That's my guess as to what they're thinking. So we've got what are called linear equations. That's what you've seen up until this point, most likely in math. And now we've got what are called quadratic. Now these quadratic ones, with the x squareds, the x, and then the no x term, should remind you of the ax squared plus bx plus c if it were all on the same side of the equation. It should remind you of AC method, and that's awesome because that's exactly what we're going to do. We're going to turn these into an AC method problem or some type of factoring problem. But what we'll do is we'll put all the variables on the left-hand side. So everything, all non-zeros are going to go on the left-hand side. And then on the right-hand side, we'll always have our 0. Once you have this set up where all your variables are on the left-hand side and your zeros on the other side, then that's when we will go ahead and factor. And what it'll look like is something times something equals 0. Well, notice if you have two things multiplied together that are going to give you a 0, then what that means is either the first piece that you multiplied is 0 or the second piece you multiplied is 0. Because that's the only way to get 0 from multiplication is if one of the two things you're multiplying is actually 0. And that's what the 0 property says. The 0 property says is once we've got everything factored, one of the two factors needs to be 0 because that's the only way for them to multiply together to actually get 0 is if one of them is 0. Because 0 times anything will always give you 0. So the thought is by breaking these quadratic equations down into factors and just dealing with the factors, it will make our problems a whole lot easier to deal with. So let's take a look at this first example, example A. In problem A, we've got x plus 3 times x minus 7 equals 0. And what we notice is it does equal 0 like we want. And they've actually done something special already. They've already factored it. And what that means is they've actually done the hard work for us. Once it's already factored, then we have to take each piece, each factored piece, and set it up and set it so that it's equal to 0. Because right now what we've got is we've got two pieces multiplied together. They're equaling 0 means one of the two pieces has to be 0. Either the x plus 3 has to be 0, or the x minus 7 has to equal 0. One or the other. So continuing along, we can continue to solve these two smaller equations. On the first one, with the x plus 3 equals 0, the quickest, easiest way to solve this would be to subtract 3 from both sides. And what that does is that gives us a solution for x. It gives us the solution x equals -3. Then we can do the same thing for the other smaller equation by solving the x minus 7 equals 0, and we'll add 7 to both sides, which will give me that x equals +7. So what this means is either x equals -3 will give me 0, or x equals 7 will make this thing 0. So both of these are answers. So we'll stick the word or in the middle. So both of these are possible answers for this equation to equal 0. Notice how many answers we're getting is not one. This is the first time we're getting more than one. We're actually getting 2 answers. And the reason is if you go back to the original problem, if you were to multiply that out, it's because your first term is an x squared when you go to FOIL, which means your highest exponent is a 2, which means you should have 2 answers most likely. It might be that you get 2 answers and they actually end up being the same answer, but you should be getting 2 answers. Let's try another one. Let's take a look at B. In problem B, let's see what we have. We have x squared plus 3x minus 18 equals 0. So we're actually set up really good this time as well. We already equal 0, which is super important when you have anything bigger than just an x. So when we've got an x squared, one side needs to be 0. Everything else is on the same side so that we can factor. Well, how do we factor this? Well, they don't have anything in common, so remember 3 terms means we're going to be doing AC method. So I need to find my A, B, and C. Remember, my A is hidden. It's a hidden 1. So A times C will give me 1 times -18, which is -18. And then we need 2 factors of -18 that are going to add up to the middle term, the positive 3x. Well, what adds up to a positive 3? Remember, I need a negative. Here is that means the only way to get a negative factor is if I do it 1 positive and 1 negative that I'm multiplying. And that'll be a -3 and a positive 6 will give me a positive 3. Remember, the reason why we're doing this is because now I can use the -3x and the positive 6 to break up the 3x here. It will break it up into a -3x and a positive 6x. And remember, it doesn't matter what order you put those in. I need to carry down my last term, my -18, and just like before, my first term, my x squared. And don't forget, this was an equation. I have to bring down my other side, which was the equal 0 part. Don't lose that. That will help you remember that these are the ones that you should be getting an answer where x equals something. All other problems say that you're going to be factoring in this chapter. These are the ones that are saying that you're solving. We should be getting an answer like x equals something because we have an equation. We have an equal to here. So don't lose that. Well, remember, now we've got 4 terms, but what do we do with 4 terms? We do grouping. Well, what do the first two have in common? They're both divisible or have an x. So if I pull out the x, that'll leave me with an x minus 3. What else do I have? On the second pair, let's see, I have a 6x and a negative 18 with a plus. I'll bring down the plus. They're both divisible by 6. So factoring that out, 6 goes into 6x and will just leave me with the x. 6 will go into 18 as 3. And don't forget, I've still got my equals 0. I'm losing it, so I want to make sure I don't lose it completely. Remember, just like when we were doing factoring, this is perfect because we have our matching x minus 3 that can be factored out now. So we factor out our matching x minus 3, and then what's left over in another set of parentheses is our x plus. What's left over is our x plus 6. And again, let's not lose the other side of the equation, which is the equals 0, because that reminds us that we're not done. Remember, we're not done because we have to set both of these pieces equal to 0. We've got two things multiplied together to give us 0. So what that means is either the first piece is 0 or the second piece is 0. So we need to set up two smaller equations, one where x minus 3 equals 0 and one where x plus 6 equals 0 to get my two answers. So on the first one, we'll add 3 to both sides. And that'll give us that x equals 3. And on the second one, we'll actually subtract 6 from both sides, solving for x, which will get us that x equals a negative 6. And those are our two answers, positive 3 or negative 6, and they both work to make our equation equal to 0. And those are our two final answers. And just like before, we're getting two answers because our original problem's highest exponent was a squared.